Hey guys, today we're going to talk about combining like terms. The reason why we combine like terms is when we're trying to simplify an expression or solve an equation, we can put things that are alike together and it will be easier for us to solve the problem. So before we begin, let's talk about some terminology we're going to need. And the first thing we're going to talk about is the word term. And that, in math, is going to be numbers, letters, or numbers and letters together, and its symbol. So remember that if the term is positive or negative, that positive sign or negative sign goes with it if we move it. And we have things like -7 and positive 4w and positive x squared and positive 3 over b. A constant is a term whose value will not change. And these are going to be our numbers, like 8, like -7, like 3/4, like -2.5. They can be positive, they can be negative, but their value will not change. We always know that 8 will always remain 8. And another term that we need to know is a variable, and that is a term whose value may change. Okay? We usually use letters to show that. So -x cubed is a variable. X cubed is a variable. We have 3y there. Okay, and we have a little note here that the number in front of the y is called a coefficient, and that is telling you how many of that variable we have. In this case, we have 3 y's. And then we have our singular letter v. So those are our variables. So in order for terms to be considered like terms, they must have the same variable or be constant. Constants are always considered like, but they must have the same variable. So they both have to have y's. And the variables must be raised to the same power. Okay? And we'll look at a few examples and see where that will come into play. And then on the bottom here we have when adding or subtracting variables, we add or subtract the coefficients, not the exponents. And we'll look at some examples of that as well. So our first example, we have 5 and we have -3. These are like terms. They are like terms because they are both constant. And we know that 5 is always going to remain 5, and we know that -3 will always remain 3. When we look at our next example, we have x and x. Those are also like terms. The base letter is the same. It's both x. It is both raised to the same power, in this case to the first power. Okay. Our next example, we have x and we have y. Okay. Those variables are different. They are different letters. They are different bases. They are both raised to the same power, but the bases are different, so we can stop there. If we look at the last example on this one, we have x squared and we have x. Those are not like terms. They are not like terms because, yes, we have the same base letter, but the exponent is different. Here it is 2, here it is a 1. Okay? Even though the 1 is not written, we understand that this is x to the first power. So those are not like terms. We have 2x and x. We have the same base letter. They are both raised to the same power. In this case, it is 1. So when we, for example, add those together, we can add together coefficients that are not alike. So here are 2 x's and here's an x. Here's 1 x. We can add those together and get 3x. So those are like terms. On the next example, we have 5bx and 5xb. If we look at our letters, or variables, excuse me, we have b and b raised to the first power, raised to the first power. We have x and x raised to the first power, raised to the first power. And we have coefficients of 5. Now, we have variables that are in both terms here, okay? We have the variables raised to the same power. The only difference is the order. Well, in this case, because it's multiplication, order doesn't matter. Multiplication, the order doesn't matter. These end up being like terms. When we have 4HC and 7CH, both terms have a C, both terms have an H. The C in each of these is raised to the first power. The H is raised to the first power. Those, again, are like terms. Just because the coefficients are different, okay, that doesn't matter. We don't need to worry about the coefficients with that. If, for example, we were going to add these together, okay, we can take the coefficients of 4 and 7 and add those together, get 11, and then we have CH and HC. We can put those in any order. It doesn't matter if you want to have 11CH or 11HC. Either of those is fine and will be correct. The next example, we have x to the 5th power y and x y to the 5th power. Okay, those are not like terms. Yes, both terms have an x. Yes, both terms have a y. But in this case, x is raised to the 5th power, and in this case, x is raised to the 1st power. Those are not the same. Here we have y raised to the 1st power, and here we have y raised to the 5th power. Again, those are not the same terms. Those are two different terms, so those are not like terms. And then the last one down here, we have 3x and negative x. So we have same base variable. We have the same exponent. In this case, again, it is raised to the 1st power. This one has a coefficient of 3. And again, although we don't write the 1 there, we understand that that is 1x. So these are like, just even though they have different positivity and negativity values. Okay, here's a positive 3x. Here is a minus x. And if we were to add those together, 3x plus a negative x, we would come up with 2x. One last thing to talk about with combining like terms is what's called the distributive property. And that's where you have a number on the outside of the parentheses. Okay? And that's equivalent to taking that number on the outside of the parentheses and multiplying it by each of the addends inside the parentheses. So we have a times the quantity of, x times the quantity of a plus b, which is equal to a times x plus b times x. So if we look down here, we have 5 times the quantity of 4 plus 6. We can take 5, multiply it by 4, and take 5 and multiply it by 6. 5 times 4 is 20. 6 times 5 is 30. So 20 and 30 is 50. Yes, with this example, we could take 10 and add, we could take 4 and add 6 together and get 10 and then multiply 5 times 10. But we just did that to show you the distributive property. If we look down here at the next example, we have 5 times the quantity of x minus 7. We take the 5 and multiply it by the x, take the 5 and multiply it by the 7. So 5 times x leaves me with 5x. 5 times 7 leaves me with 35. This is a subtraction sign, so that stays in between. So we end up with 5x minus 35, and that is simplified. And we can't do anything else with that. On the next example, we have b times the quantity of 4 plus b. So we take b times 4, and then b times b. And b times 4 leaves me with 4b. and b times b leaves me with b squared. And again, we can't simplify this anymore. And the last example down here, we have v times the quantity of v plus a plus 4 plus j. And when we're distributing, everything inside the parentheses gets multiplied by that term on the outside. Okay, regardless if there's two terms inside the parentheses or if there's, as in this case, 4. So we take v, multiply it by v multiply it by a, v multiply it by 4, and v multiply it by j. So v times v is v squared, v times a is va, v times 4 is 4v, and v times j is vj. Okay, so that is a quick run-through on the distributive property, and more importantly, working with combining like terms. We will certainly be practicing this in class, and I will see you there. Oos!